So yeah, so the last time we really did a kind of update was December. There's been a lot of work done since then. On the ACCESS ESM3 side, less work because we've all been focusing on ACCESS ESM 1.6. For the atmosphere land AM3 part of that, I think we're still got dust to deal with. It's a bit lower than we think it should be. And we have started to test turning on the land biogeochemistry, the CSIRO. Looks like that's running, but it does need its carbon, nitrogen and phosphorus pools initialized to some sensible values. The CM3 has done a 100-year run. There is a top of atmosphere imbalance. I'll show one slide on that, but hopefully we'll have an update talk in a few sessions' time. It has an ENSO from what we can see. So Gemma Jeffries interning with the ACCESS-NRI at the moment. She's been having a look at it, and that's currently running with joules, but we've got all the stuff ready to fairly simply move across to running with cable instead. On the ACCESS ESM 1.6 side, we've been doing a lot of model development and infrastructure development along with the ACCESS-NRI. We have a stand up each week to keep things moving along, and we've got some quite long spin up runs done now. Few presentations coming up through the Momentum Partnership. So Ian's heading off overseas to attend the so-called Seamless workshop. We're going to present on something which is a bit more around interoperability rather than seamless. And then the Momentum Partner Users Workshop, there is an ESM modelling session in that for the Wednesday, and we'll have a couple of talks there. And then there's the AMOS conference in June where various aspects of the work will be presented. So this is the one CM3 slide that will show. It's the top of atmosphere net radiation on the left. So decreasing over time, but still at 2 watts per metre squared towards the end of the 100 years, with a corresponding rise in global mean sea surface temperature. So on to ACCESS ESM 1.6, showed a similar figure to this in December. The colour coding was trying to indicate what was sort of on track and what was still needing a bit more work. And since December 2, there's probably a few different, or at least this one extra, Australian vegetation types to go into cable is something that we've talked a lot about over quite a long period and never got around to doing anything about. So we're trying to squeeze that in as well at the moment. This work with CSIRO has had some really good progress in the last few weeks, and I'll show some of that. But yes, at the moment, everything pretty much on track. Just a reminder of what we're aiming for. So the ESM 1.6 is aiming for what they call the assessment fast track, CMIP 7, which is really timed to try and fit in with the next IPCC assessment report. There's what they call the core deck experiments, and then the ones that are tied into the fast track. The ones with ticks are the ones that we're committed to doing either through our NEST project or hopefully with CSIRO funding, and that's some that we're hoping some of the university people will pick up and help with. I think certainly the PMIP one, there's been some willingness to take that one on. So in terms of, you know, some rough timing, we're hoping to get some of these control runs going sort of towards the middle of, or the final quarter of this year, September onwards, testing out the historical runs through the last part of this year so that we can then try and get most of those runs done through the first half of next year, the ones we've actually committed to. Just wanted to throw this up to note that in some ways doing the run is actually the simple bit. It's all the bits that sit around that, from preparing forcings, getting them into the right data formats for submission, the actual publication process, all of the evaluation that needs to go along. So just acknowledging that there's work to make all of this stuff happen. I said we were kind of getting on track and close to where we wanted to be with Access ESM 1.6, but this was the table that we have just started to put together this week to kind of highlight all the things that are still in play at the moment. So some of it is just getting the forcings, but there are still some bits of model development or getting the outputs right that we're needing to work through. Back in November, we were talking about a sort of bug fix on the convective momentum transport. And these were a couple of slides that Arnold had provided at the time. He may have even spoken to them. And there was some suggestion that fixing this CMT was improving the seasonality of ENSO a little bit, and this impact on the IOD. And then he'd also showed these biases in the basic fields. Nothing had leapt out at us at the time. What we've learned since, that this red blob here, a drier Africa, does have implications, and we were starting to see this now in some of our longer runs, where the drier Africa means lower runoff down the Nile and higher salinity in the Mediterranean, and can see that particularly in the Eastern Mediterranean, this slow growth over time, it mixes down. It's to depth. It's slowing the growth at the moment. MOM does have a bit of a hard-wired value in it. If you get to 55, then we stop, or we have to increase that limit. So that's something that we're keeping an eye on. Although Matt's provided this slide, sort of digging in a bit more detail, we were concerned that this had crept in our our latest run, where we got this CMT bug fix in, but it turns out that even without it, there was still some issue in this section of the Mediterranean, just less so in the Far East. And yeah, this showing how it changes over time, but it is all sort of confined to the Eastern Mediterranean. It gets very narrow down here around sort of Sicily and this bit through to Sardinia. So you're not really seeing much of that flow through or mixing into the rest of the Mediterranean. Yeah, Siobhan?
The suggestion at the moment coming out of the twig is that they deepen the channel there, possibly also widen it, but deepen the channel at least to the sill depth that they've got in the 1/10 of the degree model, and see if that improves things.
Yeah. So yes, there's a bit of a kind of, do we work on this or do we just tolerate it? The future runs seem to show increasing rainfall, so potentially less of a problem for present day and a warmer world than it is in our pre-industrial. Size 5 was another aim for ESM 1.6. So ESM 1.5 uses size 4.2, I think it is. There were advantages in going to the newer code base. There's more diagnostics that have been coded up in the size 5 stuff. Dave and Siobhan and Anton have worked really hard to kind of get this going, but as always with these things, it's the lesson about making sure you've got the flags correct. So this first test, it turned out this update ocean flux was set to false, and we were freshening quite significantly with the global ocean salinity just heading down. Fix that up and it's nice and stable. So these results literally from yesterday, showing now hopefully a seasonal cycle that we believe is credible, because stuff is being conserved. The size 5, at least over this 30-year period, is looking closer to the OBS than size 4 was in both the Southern Hemisphere and the Northern Hemisphere, with a slight increase in the Southern Hemisphere volume and decrease in the Northern Hemisphere volume. Again, that may be, while Siobhan's on the line, some slight differences in some of the settings on that run, or just variability.
Yeah, we think it fits in with the variability of this long April spin up one that Jan's done, but I'm still going to go through and check. There's still nothing still with the settings. We think we've tried and matched all the settings and all the constants and stuff like that between the two runs, but we're still trying to see if we can see any reason. One noticeable issue is when we switch things like the solar constant, there was about a 50 centimeter change in ice thickness in the Arctic, and again the ice thickness that was retained in the Weddell Sea was also a little bit thicker, which will come up again in one of the next plots I think you're going to come up with. But so in terms of ice sensitivities, but there is a so I need to go and check. But I think from what Anton tells me that he's picked up all the ANS settings, but we'll have to go and check if he's picked up all the atmospheric settings as well.
Yeah. Anyway, I think this is overall really good news. It was looking a bit iffy as to whether we were going to be able to make this size 5 change, but I think it's looking fairly safe to move across to that one now. New plant functional types for Australia. This is something that has been talked about for a long time, around how do we, what are some of the things that we can do to kind of own this as an Australian model. And so the way the land works is the surface is divided up into vegetation types. Each grid cell has a fraction of vegetation types, so it can be a mix of trees and grasses. There are about 13 vegetated types across the world. So at the moment in ESM 1.5, we're using a generic evergreen broadleaf and deciduous broadleaf to represent all trees in Australia. And, and the evergreen broadleaf is the same as the trees in the Amazon. The deciduous broadleaf is the same as the trees in, the northern temperate regions, for example. So not necessarily a good fit. So we're going with 2 new PFTs in ESM 1.6. I've highlighted in red Mesic and Xeric. I guess a bit of a technical names from that community, but the best way to differentiate what these are. So the Mesic is pretty much the eucalypt species, and Alex has put a few details there. Adapted to Mediterranean temperate conditions. They're generally the taller trees, more than 30 metres, thicker and vertically oriented leaves, a denser canopy, and drought tolerant with deeper roots. And the other type, the Xeric, is the more acacia or mulga type species, adapted to arid, semi-arid and Mediterranean conditions, generally a bit shorter, so 15 metres, thinner leaves, sparse open canopy, so a lower leaf area index. They'll tend to avoid droughts by being semi-deciduous, conservative water use strategy and higher temperature tolerance, so pretty much our semi-arid ones. And we're working from, Australia has a National Vegetation Information System. It has a present day and a pre-1750 map, so that's what we're kind of using as our baseline. What does that look like when you try and map it to our ACCESS grid? So we've got these vegetation types which get combined into the ACCESS PFTs, and then distribution-wise, our Xeric, as I said, is the sort of semi-arid regions. the mesic broadleaf, hugs around the coast. We will maintain a bit of the evergreen broadleaf for the very sort of rainforest type trees, and then maintaining some of our other PFTs that we currently use, so shrub, C3, C4 grass. This is a classification that's cleared, which will, at the moment, C3 crop, but will go into a mix of crop pasture and C3 and C4 crops. So we kind of done the coding to include the extra PFT types. We're trying to get that running smoothly, and then we're meeting tomorrow with some of our colleagues from the ecology community to really talk through what the parameters should be for these new plant functional types. And from there, I'm going to hand to Tilo to talk about the spin-up runs we've been doing.
Aidan, yeah.
I just thought I'd ask questions now.
Yeah.
Forget. So the plant functional types, there's not a seasonal component to those, or there is?
So these new ones will both be defined as evergreen, but they will be sensitive to moisture. Yeah.
Cool.
Do we have any other questions for Rachel before we move on?
Yeah, I have a question. Sorry, this was about the ESM, right?
Yep.
So are you saying the vegetation is prescribed, or is it not responding?
So the type of vegetation is prescribed, but the tile fraction will change over time in a prescribed manner. So we will have land use change. So for example, this area here that's cleared will be natural vegetation in 1850, and then it will shift.
But there's no response to the climate system. So there's no response that the temperature go 5 degrees warmer, that the type's changing? No.
So the things that you can't change the type, you can change how productive your system is and therefore what leaf area index. So you can have feedback through your leaf carbon pool to leaf area index, which will have some impact on the meteorology.
So yeah, the productivity can change, but not the type. So the productivity is dependent on the climate.
Is this kind of standard in the Earth system models? Because I always saw that Earth system models have interactive biology.
Some have dynamic vegetation, but it's certainly not true that every model has dynamic vegetation. And there are some arguments to be made that actually the human influence on land use change is larger than what you would get from a changing climate. So the fact that we go in and clear forests or whatever is potentially the bigger impact to capture in the model than the natural changes due to climate. And then there's all the other stuff we don't do, like irrigation and things.
But in the next cable version that we're aiming for, we will have something called demography. So it kind of comes under the umbrella of dynamic vegetation. Varying tree ages and age classes, and distinguishing primary and secondary forest. So again, something that we currently don't have in the model.
All right, thank you. Over to you now, Tilo.
Thanks, Rachel. Are you happy to keep the slides going? Yeah, thank you. Coming up to results from our spin-up runs. We started the first spin-up in December last year, managed to get something running just before Christmas so that we could make use of the quiet period and keep things running on the NCI. So the first spin-up run that we set up was mainly focused on the ocean and the ocean biogeochemistry, although it was set up as a fully coupled run with the ESM, but not bringing in the changes that Rachel described at the beginning. So it was mainly an ESM 1.5 setup, but with changes on the ocean and bringing in the new Wombat version, Wombat Lite. And this spin-up period is marked here in the blue line on the plots that you can see. On the right, just the surface air temperature. And we ran that for about 1,000 years. And you can see there are lots of vertical lines as well in this plot. And these vertical lines indicate events where we changed either the parameter settings or code changes or name lists or did some tuning in any other way. And you can see a lot happened during that period. Piers has done a lot of parameter tuning for Wombat as well, and trying to tune it to something that everyone is happy with. And then in April this year, we combined the developments that were going on in parallel, mainly on the land side in cable, with the run that we've been running since December, and making use of the initial conditions at the end of this first spin-up phase, so that we maintain the spun-up ocean and biogeochemistry. And then that's basically the next phase highlighted here in red that we started in April, and that's been run now for almost 700 years as well. And again, these vertical lines, actually there's only one, mark events where we made some changes. In this case, it's a parameter change that we applied to the ocean. So there hasn't been any changes on the land yet since we ran the model, but the focus will definitely be on the land evaluation now, and bringing in some of the other features that Rachel already highlighted as well, to ensure they are properly evaluated and we are happy with those changes. You can also see the kind of drop in temperature when we switch from the blue spin-up phase to the red spin-up phase. And that mainly comes from an update in the solar constant. We haven't updated all of the forcings yet to the kind of CMIP 7 released forcings, but the solar constant is one that we implemented straight away because we expected the largest impact from that. And that's mainly because we didn't update the solar constant in CMIP 6. We were far too advanced in our preparation, and we kept the CMIP 5 solar constant in our CMIP 6 runs and only applied an offset. So that's why you see a bigger change now. It's quite a drop in temperature. Okay, next slide, please. Starting with just some plots for the ocean. So on the left-hand side, you have ocean temperature, surface temperature on the top, and then the global ocean temperature at the bottom. And then on the right, salinity, again, surface salinity on the top, and then global ocean salinity at the bottom. Again, you can see the drop in the ocean surface temperature mainly due to the change in the solar constant. It's about 0.4 Kelvin. But it stabilizes relatively quickly at the surface, but the global ocean will take a lot longer to adjust. It's slowing down, but it's still ongoing, and it might take another, 1,000 years before that kind of stabilizes. And we are planning to run the model for at least that period in spin-up mode. But yes, also then bringing in other changes while we're running the model. Salinity, surface salinity, you can see it was increasing at the beginning, and Rachel already highlighted what the main reason for that is. It's the kind of increase of salinity in the Mediterranean. We thought it would just keep going. It didn't. It kind of leveled off at some point as well, which is good, and it also seems to decline later on as well. Just something to keep an eye on. Overall, global ocean salinity is relatively stable. The numbers that you can see on the y-axis, they're very, very small, the changes there. This is the sea ice shown here for our original spin-up with size 4.1. On the left, southern hemisphere, and on the right, northern hemisphere, and then in blue, maximum in the kind of yellowish color, the mean, and then the minimum in green, and then overlaying for the small period towards the end, we have the switch to size 5, some first results, and you can see it's overall very much in line what we get with size 4 as well. Next slide. A quick slide, the ocean biogeochemistry. On the plot on the left, you have ocean productivity, and you can see that at the beginning, ocean productivity goes up by quite a bit, probably higher than we would want it to be. So we made some changes there to the parameters as well. And then productivity decreased, now stabilizing at around 55 petagrams of carbon, which is close to the observed estimate. And Matt put here the number in as well for what we had in the ESM 1.5, which was a lot lower at 33 petagrams of carbon per year. And then on the right-hand side, you have the ocean net carbon flux. And in the spin-up and control run, we aim for a net flux of 0 so that everything is in equilibrium. It's actually quite hard to reach a net flux of 0, so we're trying to get close to it. You can see that at the first part, we were sitting at 0.4, minus 0.4 petagrams of carbon with no obvious trend. And I believe that was due to the way the model was set up. There is some boreal, and we're just losing carbon there. Switching that off gives us a net carbon flux that equilibrates nicely around 0, and just taking the average over the last 200 years, we get about 0.03 petagrams of carbon per year, which is really small. And in comparison to ESM 1.5, less than half of what we had in ESM 1.5, and in ESM 1.5, it was we were already pretty happy with that value. There's a slide showing the alkalinity. It's somewhat too high in the kind of mid-ocean, as you can see on the left-hand side. On the right-hand side, we have the observations, and somewhat too low at the surface. And I think Piers and Matt are planning to do a parameter change here as well to decrease the gradient. This will have an impact on the carbon uptake and will perturb our net flux again. But if we keep the model running, which we intend to do, then we should get in balance again after a couple of 100 years, hopefully. Next slide. Switching to the land, you can see the productivity here for the land. GPP or photosynthesis. On the top left, you have the time series for GPP. In black, we have our original ESM 1.5 pre-industrial control run, 500 years. And then in red, it's our new ESM 1.6 spin-up, which already exceeds the 500 years. They're very similar in the mean value. Although we had some changes in the vegetation maps for more trees in the higher northern latitudes and some other changes as well, but there were also other changes in the parameterization, and overall the difference is relatively small. There's also the spatial maps on the right-hand side for ESM 1.5 and ESM 1.6, and the difference plotted in the at the bottom. And you can see that, yes, in the northern hemisphere, high northern hemisphere, it's somewhat higher, but there are also areas where productivity is lower. What stands out a little bit is that our variability is quite a bit smaller in our ESM 1.6 run. And that's something we haven't really figured out yet why that is. So need to keep an eye on that. Then the land net carbon flux, again, in the spin up and control, we aim for a net flux of 0 here. The plot shows in black the ESM 1.5 net flux for the 500 years of the control run. It was very small in the ESM 1.5, very stable, 0.02 petagrams of carbon per year. It's even better now with the ESM 1.6 version, almost an order of magnitude better, although I don't think it really matters anymore. It's because it was so small already, but it's great to see that how stable it is as well, without any drift. And again, the variability in the net flux is quite reduced to what we had in the previous ESM version. Just some next steps and where we're going with the future development. We have NESP funding until the end of 2026, so we're aiming to complete the fast track submission with ESM 1.6 by then, and it aligns with the current deadline for the fast track as well. Just to highlight that all the testing that we are currently doing is in concentration-driven mode, so we don't have a fully interactive carbon cycle at the moment. But because our net flux for land and ocean is so close to 0 and relatively stable, we could start emissions-driven test runs as well. So with a fully interactive carbon cycle, but no prescribed anthropogenic emissions. I believe the CMIP 7 forcings for the PI control run and the idealized runs are now almost completed. And they're not all implemented yet. So it was mainly the solar constant that's already updated to CMIP 7. We're planning to bring in those updated forcings in the next phase of the spin up. Ozone and nitrogen deposition is not available yet, and we have to wait until that is released. And I already said that we are going to continue the spin up and then bring in the changes when they are ready. That will be mainly focused on the land. The ocean BGC is almost finalized, apart from the change around ocean alkalinity that I highlighted earlier. And we are planning to run in this kind of spin-up configuration for another 1,000 years. So because the ESM is relatively fast, we get about 500 years per month, so we can afford to run it for a bit longer to ensure that we're happy with the performance before we switch into the control run and into the production runs. iLAMP is also pretty much ready to go now, and we're planning to use it more for the land evaluation in the future. We also have a first test run set up for the 4x CO2 experiment, and I will come back to that in a minute. And yes, the idea is that we start with the PI control run and the DEC and idealized simulations in the second half of this year. And just very briefly, some results from our 4x CO2 run that we set up to estimate the equilibrium climate sensitivity, and it's a plot that Martin put together. We had a climate sensitivity of 3.9 in ESM 1.5. In ESM 1.6, we currently have about 130 years available for the 4x CO2 run. And Martin calculated here a climate sensitivity of 3.36. And if we compared it with the ESM, 1.5 over the same period. It's still somewhat lower, and Martin estimates that once we have completed the 4 times CO2 run, the climate sensitivity for ESM 1.6 will be about 3.5. That is lower than what we had in our previous model version. I think the CMIP 6 AR6 best estimate was around 3. It's not something we should be concerned about. It's not getting higher, but it would be good to better understand why it's lower now. And Martin has done some analysis on this already. So we using the Gregory method to calculate the climate sensitivity, and that's basically based on the top of the atmosphere radiative imbalance and the temperature change. And here are the different components. And Martin highlights that the largest difference here is in the shortwave clear sky radiation, and that's probably then tracked it down towards a change in the ice albedo, I believe. But I think Martin is online as well, and he can answer questions to that if there are any. So that's all we have prepared for today.
Thanks very much, Tilo. That was a lot. Can you just go to the previous slide? I was halfway through making sense. The one with the the one before this. Yeah. We can just leave it there for the moment. Do we have any questions for Tilo or Rachel, if anyone have come to your mind?
I just wanted to follow up on the salinity issue in the Mediterranean. It seems pretty logical to me to do something to the exchange. It's because I would say most climate models have difficulty getting this salinity balance right in the Mediterranean. It's just this bottleneck of high evaporation and a small passageway. So if you can slightly tweak either the gateways to make it mix more, or you can use the...
Did we lose you, David, or it's just me?
No, I think he just dropped out.
Okay. We can wait for David to come back.
Yeah, it says he's still there, but he's frozen, right?
Yes.
Yeah, one of the comments that came up yesterday in discussion was we actually have a wider Gibraltar than we have between Sicily and Tunisia, which is a bit strange.
So suggestions have been made to address this, and I guess that's another change that we have to make and that we have to test. Also, what we haven't mentioned yet, I think Rachel briefly made a note on that earlier, is that with the 4 times CO2 run as well, we actually see an increase in rainfall over Africa, which will also increase the freshwater inflow into the Mediterranean, and then somewhat I
saw those plots from Ian. I didn't see that it changed it enough. I saw it was a slight change.
Well, it's also a short period.
Yeah.
So, but I guess the message is that, with over the historical period, we might actually see an increase in rainfall. We're running with pre-industrial conditions at the moment.
Yeah.
And we use these forcings repeatedly over a very long time.
Yeah, because it's 700 years, and then it's just built up so much.
Exactly. We might not actually see that in the kind of historical simulation, that feature at all. There's also the possibility to reset the tracer at the start of the control run, at least locally.
Yeah, I think
it will just increase the gradient again.
Yeah.
But sorry, Dietmar.
Andy Hogg didn't like the sound of doing that. He thought that was a very strange thing to do. But certainly changing the sill depth and possibly widening that Sicily channel or whatever we're going to call it. I think it's probably got an official name. We should probably start using it. I think then Sicily and Tunisia. Then we probably should look at that possibly, if we can, easily. Yeah.
Sorry, just Dave, I think you kind of dropped out halfway through. We kind of went through a little bit of an answer.
It's all right. We can chat another time. I'm sorry. The Wi-Fi failed. Now I've plugged in a cable. It's I guess you got plans to fix it. So yeah.
We'll come, if there's time at the end, we'll kind of come back. So Dietmar, you had a question?
Yeah, I was wondering a little bit about your equilibrium climate sensitivity, so you said it's 3 point something. Does that mean this is a response to a doubling of CO2, or but your graph for 4 times CO2 didn't look like 6 degrees?
You have to divide it by 2. It's the way.
Yes.
It's because it's a 4 times CO2 run.
Yeah. But this is less than 5 degrees warming. But this is what I bought your graph on the left, upper left, and it's about 5 degrees.
Yeah.
And then how do you get to 3?
The Gregory, because we haven't come back to radiative balance yet, and the Gregory method, it assumes it's linear, you put a straight line through it, and you extrapolate it to 0 net radiation.
So you're expecting another 2 degrees of warming, and then you get to 3 point something.
If you ran out, several hundred years.
Okay, then got it right. Maybe another question that is in my mind. So CMIP 6 was ESM 1.5. Now CMIP 7 years later, is ESM 1.6. Doesn't sound like a great development. So I wonder, what is the logic between your naming 1.5 and 1.6, and why not ESM 2?
Because we already have a CM2 version, and an ESM2 would be basically switching on the carbon cycle for CM2. The ESM 1.6 version is really based on the ESM 1.5 components. So the logical step was there to have the increase in the number there, and then we also have the ESM3 development, which will come in at a later stage. But
so the ESM 1.6 is substantially different from the CM2.
Yes.
All right.
So the CM2 has a newer model component, higher vertical resolution. Yes, I know you're saying yes, it's a 7 years gap between the MIPS, but it's actually not a very long time for model development. And other modeling centers struggle with that as well, to provide, substantial new models within this relatively short time frame. So the UK Met Office is also providing an updated version of their UK ESM model for the fast track. And because they can't get their next generation model ready in time.
Yeah. So I understand this correctly. So the aim is to get ESM 1.6 and then the CM3, right, into the CMIP 7. Or
so version 3, including CM3, we are aiming for a CMIP 7 later submission beyond the fast track timeline. So aiming for the community MIPS.
Okay.
Matt.
Okay, just a quick comment just on the Mediterranean again, that the issue there is very similar to another issue that is in the ocean model around the Red Sea and the Persian Gulf, which has a fix that's in the code. So I just mentioned that again, just for people's awareness that that there is that approach as well. It's a horizontal mixing that Dave B applied to back in ACCESS 1.3.
We could try and do that mix across that salinity, where we physically move the salinity across, but we thought we'd lower the sill depth first and see if we could get the sill depth more realistic to what the actual sill depth is in that strait. Was one of the discussions.
Just making sure the option's on your radar, that's all.
Yes.
Let other people handle that.
Yeah. We're still even wondering what to do for the CM. If we do have a CM3 version again with the Gulf. Actually, the Red Sea is not too bad, but the Gulf is really poor in the CM3 1 degree version.